Okay guys, so let's get back to the scoring system in BLAST. So why the score is important? Because score is the number that tells us the quality of an alignment. So higher the number, higher is the similarity, and those scoring schemes they depend upon the scoring system we use. That is what kind of substitution matrices we are using, what are our gap penalties. So all these things, they add up into your score. Assessing the significance of an alignment is an important aspect in order to find the evidence for a true homology versus a by chance relationship between two sequences. So you get those sequences aligned together. Now you are interested in whether these are truly aligned with one another or is just happened by chance. So in order to do that, you need to do some significance tests on your scores. So there are two approaches to assess the significance of scores. One of them is Bayesian approach and the other one is EVD, or extreme value distribution. So in Bayesian approach, you go for the probabilities, which we call them as prior probabilities. So you are interested in the probability that these sequences are related, which is given by P M while XY, and we can apply Bayesian calculations or formulas in order to get these probabilities. So we take the probabilities of we take two probabilities over here. One of them is probability of the match model, that the sequences are related, which we called as P over M, and second is P of R, which is that the sequences are not related, or we can say the random model, so they just got aligned at random. So PR and PM both are related with one another. So through this equation, so P of R plus P of M is equal to 1, or we can say P of R is equal to 1 minus P of M. The posterior probability that sequences are related and the match model is correct, we can get it through this equation. So we plug in the probability. So this is through, remember, Bayesian equations. So we come up with this equation, we further expand that, and where we incorporate our random model also. So after playing with those equations and after doing some other calculations, we come up to these equations, which is one of them is S dash or S bar, that is equal to S plus log of P of M over P of R. So same concept guys, log odd ratios, match versus random. So that will give you the score down below. So S is actually this log of Px y while M, and that is divided by Pxy while R. So that is your S. So for that S, you can put in the you can put this value of the S in the above equation, or if you look into the above equation, so that is where this S is given by log of Pxy while M divided by Pxy while R. So you come up with this score, which is S dash or S bar. And we can do further, go further, where we can also have this prior probability of this finding a match, which is a true match, is given by this simple equations where we have Pm while xy is equal to sigma on S dash. So S dash, we get it in the previous equation. So these two things, then they are correlated with this, where sigma x is actually we call it as a logistic function. So that is given by this expectation of x divided by 1 plus expectations of x. So this is how these whole sigmoid functions can be explained, or this we call it as logistic function. Logistic function is a sigmoid function, so that is a shape like this. We have seen that in our previous section where we were talking about probability values. So that has some values which are actually related to the probability of finding different events or different observations under the curve. So this is how it looked like. So as far as these equations or these statistics are concerned, this is the whole area. We are not interested in the actual calculations, but I just want you to know that these equations, they exist, and this is how they look like. So we say that in this section, what we can conclude over here is that assessing a significance of an alignment is an important aspect in order to find evidence for true homology versus a by chance alignment.